today we go one step farther with scatter plots. Today we're going to be finding the equation of that line of best fit and then using the equation to make predictions. And I want to highlight that. That's what this is all about. We want to be able to make predictions about what's going to happen next. Okay, so we're going to go through that scatter plot, making again a little bit, and then we're going to throw in some technology here so you can see how a computer might be involved in doing all these things. So consider the following data. Some data was collected at different time. Measurements were taken here, and this is where that independent dependent thing comes in here, because somebody made this decision. They decided that we were going to measure the height of the hot air balloon at different times. So that was the independent variable. They got to choose that. They said, okay, at time 3 minutes, we'll take a measurement. And at time 4 minutes, we'll take a measurement. And so that makes this second column the dependent column, because that's the part we really couldn't control. We just measured that, okay? So it says make a scatter plot on the graph below, draw the line of best fit, and then find the equation of the line of best fit. That's the part that's new today, find the equation of the line of best fit. So I could go through, and I encourage you to do it. If you haven't done a lot of scatter plot, or if you had trouble with the scatter plot homework at all, there's a graph there. Go ahead and make your own scatter plot with your own scale. I want to show you how to use technology to do this, because moving forward in science and so on, they probably were going to let you do it with technology. So watch carefully these steps. Oh, by the way, I've included all these steps down below on how to do this in Microsoft Excel, and even how to get a line of best fit. I won't do that with the technology here because I got to teach you to do that by hand, but Excel can do that as well. Okay, so just watch the video and you can look at the instructions later. It says, first I want to select this table. And it's a little hard on my iPad, so it just takes a minute here to get that whole table selected. And I'm going to copy that, and I'm going to go over to Microsoft Excel, which I already have open. Hello, Chloe. And I'm going to click there, and that allows me to paste my whole table in there. Ooh, I got some extra stuff in there, so I'm going to get rid of that. I must have highlighted some stuff that I didn't really want there. Let me get my keyboard activated here. And we'll get rid of some of this other stuff. I don't need all of that. I just need those two columns. There we go. Now, then I'm going to highlight those columns right there, like so. And I'm going to go to Insert, Charts, and it says Scatter Plot. There's lots of options there. I don't necessarily want to get into what all the options mean. I'm just going to select the first one, and boom, look what it gives. It gives all the titles, it gives the scale, it gives the graph and the guide. That's cool. But here's what's really cool if you're doing like a science experiment or something like that. I'm going to copy that. I've hit Control-C on my keyboard. You could also hold on it and press the copy button and then go back into Microsoft Word. I'm going to get rid of that grid because I'm going to do better than that. And now I'm going to go Control-V for paste. Oops, it didn't take the copy and paste, so let me go through and click on this thing, select objects, copy, and then over to Word and paste. Isn't that nice? Oh, for your science projects. Boom, boom, scatter plot right in. I'm going to make it a bit bigger because I want to work with it. And there it is right there. How good is that? So something to remember for your science classes. Make the scatter plot, done. Don't get me wrong. I think you should be able to do that by hand, but hopefully you did that with yesterday's homework a bunch of times and you found out that making a scatter plot is not a big problem. This makes one perfectly. Then they said draw the line of best fit. A little difficult for me on the screen here, just the nature of Word and so on. So I'm going to insert a straight line here, and the straight line pops up sort of wherever it wants. And then I got to go and I got to select this thing. I got to grab the ends of it and sort of put the ends of it where I want here. So I don't know, something like that, and no, I don't really like that. There. I'm pretty happy there. It's hitting 3 of the points there, 1, 2 below, 1 above. Not perfect, but you have to decide for yourself what looks perfect for you, okay? Now, once I've done that, in fact, I really I think maybe just a smidge lower there. Okay. Yeah, because that 1 point's just a little bit low there. That 1 point's just a little bit high there. Sort of meets three of them. I'm happy there, okay? Okay, so I drew the line of best fit. Let's go back up to here. And put a little check mark. When I have a lot of things to do on a question like this, I like to check them off as I go so I don't miss anything. Okay, now's the big part of today's lesson. It says, slope. Find 2 good points to find the slope. Now, you won't always find beautiful points depending on how big your grid paper is. And this program has selected very big grid paper here, and that makes it a little harder to find good points. But when you draw it yourself, you're using regular graph paper, so you shouldn't have too much trouble finding good points. And so by good points, I mean points like this, right on grid crossings. And there's another good one, right on grid crossing. That's what I mean by good points, because when you do that, finding the slope is just rise and run here. It rises by 140. Watch that scale. It runs by 30. And so now I've got the slope here. M is 140 over 30. Now for this particular question, we're going to be quite happy with decimals. I know that fractions has been a big deal in this course so far, but you'll find moving forward that if you're dealing with a real hands-on type problem like this, that decimals are probably fine. And I hope as I do this question, you recognize why decimals is fine in this question. So I'm going to go 140 divided by 30 in my calculator, and it gets 4.6 repeated. I'm going to keep 2 decimal places. I think 2 decimal places is fine for accuracy. For height of a air balloon, we don't really need to get it down closer to the centimeters. And then it says find the y-intercept. And finding the y-intercept is all you got to do is draw the line far enough, which I did here. See, the y-intercept came out to be 0 here. Now, it didn't have to come out to be 0, and maybe you chose to draw your line somewhere different, and you got a slightly different y-intercept. There's no saying mine's better or yours better. We're just making predictions, and our predictions will probably be pretty close, because if you chose a higher y-intercept, you would probably get a lower slope, so our answers would come out pretty similar. So I'm going to write that whole equation here. Y equals 4.67x plus 0. And again, if you got a different y-intercept, that's fine. It's no problem. It's just a prediction we're making here. I'm going to do a little better than that, than the y and the x. I think it's h equals 4.67 times t. That's a better use of variables in the equation. Again, you can use y's and x's, but I just find that when you use the variables that are really actually involved in the question, it's a little easier to tell what's going on here. And I left the plus 0 at that time. And here's the big question. Use your equation to predict the height of the balloon after 80 minutes. Take a look. My graph only goes up to 40 minutes. This is the whole point of finding the equations of line of best fit, because we don't want to have to graph on and on forever. We want to be able to make predictions easily without having to draw the graph forever, and this equation will do that. My equation says h equals 4.67t, and it said after 80 minutes, I don't need to go any farther with the graph, 4.67 times 80. If you had a different equation, that's good. Compare your answer, because I think you'll find that they'll be reasonably close. And I get 374 meters, rounded off. That's about where the air balloon will be. That's all there is to it. Let me just review the steps. Make the scatter plot, of course. Draw the line of best fit the best you can. Okay, and then find the equation of the line of best fit. There's 2 steps to doing that. Find the slope. Find 2 nice points as close to grid crossings as you can for accuracy. And then just if you draw the line back far enough, you'll get the y-intercept right there. And it won't always be 0. It just happens that the way I drew this one, it came out to be 0. But it doesn't always have to be that. Then you have your equation. Once you have your equation, whatever they want you to do with the equation to make predictions is pretty straightforward stuff. Even if they want you to put a height in, let's say this question asks for height, well then I would have put the height on this side and solve the equation the other way. It would be an extra step, but not a really big deal. Once I have the equation, you don't really care anymore about what times or heights they give you, because you don't have to go back to your table of values. You don't have to go back to your graph. Okay, now the Microsoft Excel instructions are there. Exactly what I did all the way up to adding trend line. Now, iPads doesn't have the feature to add a trend line, but if you're doing it on a computer, you'll be able to add trend line, and it'll make the line of best fit even better. It'll come up with the equation of the line of best fit. How did I do that? This is the equation they came up with. I'm having trouble seeing that. 4.5x plus 4.9. That's what they came up with as the computer, the perfect one. So how was mine? I got 4.6, so mine was a little different than theirs, but they had plus 4.9. So they had a slightly higher y-intercept. So they think a better line would have been a higher y-intercept. Maybe you agree with them, and a slightly lower slope, and maybe you agree with that too. The answer, if you use their equation, will come out pretty close. In fact, I want to check it now. I want to see how close it comes out to. So what did they say? We want it after 80 minutes, right? So zoom in again. 4.47. So 4.47 times 80 minutes, and then plus 4.97. So the computer answer came out to 363 meters. What did I get by hand? 374. So I was off about 10 meters there by doing it by hand, which I think is pretty good doing it by hand like that. Like that's not a bad result. But you can see the advantage of technology there. Technology gets it right down exact and knows exactly what the best prediction would be. That doesn't mean the actual height of the balloon would hit that prediction. It just means that's what's, if it follows the data the way it's been going, that's the height you'll get. Okay, very, very quick homework tonight. Just a couple of these to do, and that's all there is to it. Have a great day.